Hello, and welcome to the first episode of Now You Know. Today is the first episode, so I'd like to give you a little overview of how the show works. Every month we will have a new episode, and it'll usually have some occasion depending on what's going on in the world and what's happening. This week is one of my favorites because it's just the end of Shark Week. And so we're going to be talking about elasmobrachts. Elasmobrachts are the group that includes sharks, rays, and a group called chimeras. These are all in the family of cartilaginous fish. So we're going to answer some common questions and teach you all you need to know about elasmobrachts. So one of the first things we need to know is about the elasmobracht family. There are multiple species of cartilaginous fish in the world, approximately 500 different species of rays, which are in the group Batoids. There's also a species called chimeras, which can also be called rat tails, rabbitfish, or ghost sharks. There's about 40 different species of those. And there are the sharks, which are just called elasmobrachii, which are the most diverse group of this family. There is many different species of sharks, ranging in size from the pygmy shark, which is 9 to 11 inches long and weighing only 1/3 of an ounce, to the largest shark in the world, which is the whale shark, which is up to 33 to 36 feet, rarely getting up to 40 feet, and it can be 10 plus tons, and the record is just over 20 tons. These are unique species because they developed many millions of years ago. And one of the creatures that also developed many years ago, is one of my favorites, is the horseshoe crab. The horseshoe crab and the shark arrived around the Silurian and Ordovician periods. Those were a long time ago. And the first shark appeared around 400 million years ago. That was the first modern shark. It was a very unique species that was in the Psittaciformes, which are the dogfish. And that species was Psittaciformes. That was, again, in the dogfish, which is one of the smaller species of sharks. And the amazing thing about sharks is they haven't changed very much, just like the horseshoe crab. And one of the interesting things that they also share with the horseshoe crab is their blood. The blood of a shark is very unique. It has 10 times the antibodies of human. That means they can fight off more types of diseases than humans can. Sharks are a very resistant species as well to many different types. There's even been myths developed that sharks cannot get cancer. That is actually a myth because cancer is caused by mutated cells, and mutated cells are not caused by a disease typically. They can be caused by radiation and all different types of things. And no creature is actually immune to cancer as far as we know. And there are other diseases that sharks can get as well, such as gutworm, which is a parasite. And with parasites, there's also a parasitic species of shark. This species is called the cookie cutter. It is a very small species of shark and is also bioluminescent. These species will glow in the dark after they're caught for up to 3 hours. They are a very interesting species of shark, and they're called the cookie cutter because when they bite a creature, it leaves a perfectly round shape, like a cookie cutter. Now, as I mentioned, sharks are very old. There are many different species of prehistoric sharks, including these ones, which are some teeth of prehistoric sharks and vertebrates. These teeth were found around 45 to 70 million years ago. The dinosaurs went extinct 65 million years ago, so that's just before them. As I mentioned, some of the oldest sharks are 400 million years old. There were also other species of prehistoric fish. The ray-finned fishes are what we have today. We have cartilaginous fish and jawless fish today. But there's also two other species of fish that we used to have that are basically extinct. The lobe-finned fishes, which actually branched off into bony fish, and the closest living thing today is a lungfish, which is a fish that can actually breathe air for short periods of time. And there's also the placoderms, which are completely extinct. These fish are bony plated heads. That's what they're most known for. And they actually do have similar fish. They kind of look like catfish, but the catfish are now in the ray-fin fish, which are also known as bony fish. Ray-fin fish is actually the generalized term for anything after cartilaginous fish development, and it's very interesting. They actually have rays in their fin. That's why they get that name. And there are many, many different species of sharks over the time of evolution, and some amazing adaptations as well. Many years ago, there was actually a type of shark that is now extinct. It was the ancestor of modern rays. It was called the banjo fish, or rhombotus, and the reason they called it that was because not only its body was rhombus shaped, but the evidence we have of it are from its teeth. These teeth are actually rhombus shaped, and they have 2 triangles on each end of the rhombus, and they actually know that this was leading to rays because they were raised like a shark's teeth, but they also were flattening out. They weren't pointed like a shark. This happens to be how we know rays develop flattened plates for crushing shellfish, is from the rhombotus teeth. They actually have fused jaw plates now, the species of rays, and these are very interesting. And the banjo fish was actually closely related to a species called a skate. A skate is a type of ray without a stinger. And we have more transitional fish as well, such as the angel shark, which is a species of shark that is also known as the monkfish. And there is actually one of the most endangered species of sharks is the angel shark. There are 7 on the site's red list, which is the list of some of the most endangered species in the world. And they're actually the most endangered group of shark due to humans and sharks interactions. Now, there are some predators of sharks besides humans. Humans are the #1 predator. They actually use sharks for shark finning. And they actually do have other predators, including other sharks. And the biggest predator is usually orcas. Orcas will actually eat sharks, such as great whites and some of the smaller sharks. The sperm whale will also eat smaller sharks. They're carnivorous. They will aggressively defend their young as well. The sperm whale and orca are mammals, and this is very interesting because there is one major difference between aquatic mammals and sharks and other species of fish. The mammals use their body in a swimming manner like this, up and down with the swimming manner. This shows a seal, which is one of the aquatic marine mammals. Sharks will actually move their body side to side in the same motion but in a sideways. So they'll actually move their tail back and forth, and marine mammals will go up and down. This is the main way we use to distinguish mammals from other species of fish and other aquatic animals. Humans are one of the exceptions. We do swim underwater both ways, which is interesting. And there are actually several species of sharks that are actually adapted just like mammals, because they have adapted very special ways of getting around, including the bull shark, which is a species that can adapt to fresh water as well as salt water. They have been seen in rivers in Australia, Africa, and North and South America. Most interesting is a shark that can swim up the Amazon River. They have been reported in different parts of the Amazon, very far up, away from the ocean. Now, these sharks are very unique. They actually, the saltwater sharks are actually produce less salt than the ones in fresh water, which is an interesting thing. Sharks actually naturally produce salt, which they excrete from their skin, which is an interesting fact about cartilaginous fish. They are also ectothermic, which means they are basically cold-blooded. and they have to adapt their temperature due to the water environment around them. They are like reptiles, but they do not need the sun like reptiles to gather energy. Unlike reptiles, they will actually get all the energy they need from food, which is surprising. So they're basically a cold-blooded animal that actually gets thermal energy from its food. There are many different rows of teeth in sharks for eating. Like I said, the batoids and rays have smaller, flattened teeth, while the sharks have pointy, razor-like teeth. There are also some middle-type sharks that have flatter teeth, like the nurse shark and lemon shark. They have flatter teeth, not as razor-sharp, but still can be painful. The sawfish is interesting because they have a bill-like extension that looks just like a saw. They actually use that to immobilize prey by thrashing it around, and it's very interesting. That's their method of fishing and catching prey. Another method of catching prey is camouflage. Camouflage is used by a couple different sharks, like the angel shark, which we mentioned earlier, and also the wobbegong, or carpet shark, which is native to Australia. They blend in with seaweed, even growing tassels on the front, so they actually blend in with the algae mats that they use to camouflage themselves. There's other ways of hunting as well, such as the hammerhead shark, which is very interesting. There's 3 species: the great hammerhead, the scalloped hammerhead, and the bonnethead shark, which is the smallest of the 3. But they actually have not just eyes on both sides of their head, but electrical receptors, and that actually use those on each side to help pinpoint which direction their prey is. These electrical receptors are called ampullae of Lorenzini. These were used to detect the natural magnetic and electric fields of different living organisms. These are generated, these magnetic and electrical fields, by all organisms. It's usually electrical, created by a heartbeat and signals from our brain. And every creature's body actually has a natural magnetic shield. In sun sciences and healing areas, that's called the aura. That is actually can be detected in certain measurements of magnetism. And we actually know that sharks are actually repelled by magnets. It's a recent study that if you watch Shark Week, you would have seen that study. Sharks will not attack things with magnets on them, which they recently did a study on, but will attack things, the same exact item, without magnets. But as soon as the magnets are attached, the shark will leave. This is interesting because a long time ago, the Navy did testing on shark repellents, and they found one chemical, copper acetate, that is actually a shark repellent. It's not very well documented, the study, but it's the only chemical they found sharks were completely repelled by. Copper is actually a metal which is very highly conductive of electricity, which we know magnets are also highly conductive of electricity, but copper is what we use in wires, electrical wires, to produce electricity. And most of our electricity is actually produced with magnets, which is interesting. A magnet going around a motor, which will create electricity. Now, this is very interesting. We have other research on sharks recently. Stereochemicals are also shark repellents, one of the more recent developments. These are actually hormones that are sometimes made of sharks and other species of fish themselves. And these stereochemicals are hormones that actually work in the brain of the shark to actually switch from a feeding mode to a fear mode by producing adrenaline in the shark's brain. This will actually cause the sharks to often flee the area, so it's not a very productive way of keeping sharks away if you're trying to study them, because they'll often leave the area, and you actually want to get close to them when you're studying them, so it's not very effective. Sharks are interesting with their skin, because their skin actually has this material like scales. They're called dermal denticles. They actually prevent things from growing on the skin. And these actually also help streamline them by trapping small pockets of air between the scales. This is unique to sharks. Other fish do have scales, but these dermal denticles, as they're called, actually mean teeth skin. They're actually a different material than scales, and they look just like teeth under a microscope. There is there is a unique feature to distinguish old sharks from new sharks. These are the number of gills. 6 gills are older sharks, more primitive, like the frilled shark, which is one of the most unique sharks. It's one of the oldest species we know of. And then there's 6-gilled sharks, which are also close. And then there's the 5-gill sharks, which are the newer species of sharks, which developed more recently and in modern times, close to when the dinosaurs were around 220 million years ago. That's about halfway through the development of sharks, which appeared 400 million years ago. And that's interesting. We can tell the primitive sharks from the more modern-day sharks that way. The chimera, which is the rat-tailed fish, is an elasmobrach as well. And these are a very primitive species. They are more fish-like than shark-like. They're very small, but they're actually defined as an elasmobrach because their skeleton is made out of cartilage instead of bone. This is unique because they are all other features that belong to fish, but because of this, they are considered in the shark family. Now, there are many different species of chimera, around 40. There's the shovel-nosed chimera, which is a deep-sea species. There's also a couple shallow water species, but most of them live very deep. And some sharks that live deep are even bioluminescent, such as the cookie cutter or the megamel shark, which is actually a filter feeder like its cousin the whale and also the basking shark. And they actually have a bioluminescent mouth to attract prey like jellyfish and small bioluminescent creatures called copepods, which actually in shallow waters can parasitize other species of sharks, such as the Greenland shark, which has a copepod species that lives on its eyes. And these copepods actually grow big enough that these copepods sometimes develop parasites as well. So it's a parasite living on a parasite that grows on a shark. These parasites actually do not harm the shark in any way, which is surprising. The shark may go blind, but the shark actually, it's been proven to not affect the shark in any way, because the shark continues on its life using a sense of smell and electricity. Now, sharks are very unique, especially the deep-sea sharks. There's also the goblin shark, which can extend its mouth, and they actually have a long nose that extends past their head. That's how they get their name, the goblin shark. In Japan, they're called tungunzei. These are the Japanese word for goblin shark, which actually means demon in Japanese language. And the interesting thing about goblin sharks is they're actually the only species in their family. They are not related to any other species of shark. They're the only ones in that group. There's also the Port Jackson shark, which is a shallow water shark that is very interesting because it lays spiral egg cases. There are many interesting facts about shark reproduction. That's actually one of the ways you tell male from female sharks is look at the pelvic fins. These are the first set of fins on the bottom. This will actually be elongated in males to form the clasper, while the females do not have these. These are used during mating. There are actually 3 forms of shark reproduction. There's oviparous, that's the eggs develop inside the body, and these eggs will actually hatch inside the body and then the sharks will come out. There's oviviparous, which is egg laying. They'll actually develop eggs and lay them on the seabed, But there's also viviparous sharks, which don't develop eggs at all. They just form inside the mother's uterus, like in mammals. And sharks like this include the great white, and in the great white there's actually been reports of intrauterine cannibalism, which is where the younger sharks eat, or the sharks will eat some of the undeveloped eggs before they develop, and this actually helps the shark to grow. It's actually what they eat. This is interesting because this is not reported in many different species. It's actually one of the only species that we know of intrauterine cannibalism, which is very unique in sharks. There is also, since 2001, there's been reports of virgin births, or autonomic parthenogenesis. This happened in 2001 with a hammerhead shark in Omaha's Henry Doyley Aquarium. This was actually interesting because they thought maybe it was from in the wild or another shark in the tank. When they did DNA tests, they found out that the genes were actually all from the mother. This process happens when the embryo of a shark develops, and the egg is actually fertilized by a cell from another type of cell from the mother, which doesn't happen very often, but has been reported in hammerheads and a few other species of shark as well. This is unique. We don't have many creatures that give virgin births. So we also have a few species of reptiles that will do this, and lizards especially. But sharks are unique. They're one of very, very few species of fish that will do this. Sharks have very interesting anatomy. Their liver is actually oversized, and this developed from fish later on in fish to become the swim bladder. So sharks don't have a swim bladder, so they need to swim to stay afloat. They do not need to swim to breathe. This is a misconception. Some sharks do need to keep moving just to float, but there are sharks that live on the bottom, such as the angel shark, which will actually stay put for days and sometimes even weeks, waiting for a meal. The liver is actually filled with an oil that we call squalene. This is actually used in pills in different parts of the world for different reasons. They actually have other parts of their anatomy that humans use, such as their fins. We use that for shark fin soup in China, which is why there's many long lining for sharks illegally in the world. Sharks have many different species of fins. The pectoral, which is the arm or side fin. The caudinal, which is the tail fin. They have the dorsal, which is the top fin, and some sharks even have a second dorsal fin. So there's also the pelvic fin, which is the first bottom fin. And then behind that, they'll have the anal fin, which is further back than the pelvic fin. And as I mentioned, sharks have amazing internal anatomy. Their intestine has a spiral valve inside that goes around and pushes food out through their body. So that is an adaptation that actually keeps sharks' digestive systems moving constantly. This actually allows them to eat and keep their metabolism high. This is very unique. There is also another interesting anatomy of sharks within the brain. It's called tonic immobility. And that's when you flip a shark over, they'll actually enter a state of paralysis. This only happens in most sharks. It doesn't happen in all sharks. It has been thought that it does occur in species like the great white, but we're not entirely sure. There is recent testing being done on this. There's many different species of sharks that we know don't show tonic immobility as well. Mostly the larger sharks are the ones that don't show it as much. The smaller sharks are much better demonstrators. And this leads to my next subject, shark attacks. There's only about 10 fatal shark attacks each year or less. These are fatal shark attacks. There are shark attacks that are reported but do not end fatally, or some don't even end in injury. But it's more likely to be struck by lightning than a shark attack. In fact, there's a 1 in 3 million chance in the U.S. for you being attacked by a shark. And that chance actually increases the further out you go. So if you're really close to shore, it's actually a very low chance. Most of the sharks actually live further out. We do have some species of sharks around here. Closer to Cape Cod, we have the chain cat sharks, which are at the Seacoast Science Center. You can see those where I volunteer. There's also great white sharks off the shore occasionally. Those are typically farther out. You hear about those off the ledges in Massachusetts. You'll also hear about the dogfish sharks. Those actually are amazing. They can actually have these little poisonous spines on top front of their dorsal fin. They're called spine dogfish. There's also other species of dogfish as well, such as the mandarin dogfish, which has electric sensing barbells, like a mustache kind of, which is unique. There's a lot of different reports of sharks. Sometimes you'll even find the mermaid's purses, are what they're called. They're shark egg cases. Sometimes you'll find those washed up on shore in spring. And it's very interesting to find those, because the shark, if you shine a light through that, you can actually see the baby shark developing, as long as the shark is alive. So that's interesting. And there is many species of sharks, as I mentioned before. Sharks are a diverse species, but you won't see diverse species in aquariums. This is because most of the species live deep down, and it's hard to keep deep-sea creatures because of the pressure differences. There's the aquarium in Japan, Okinawa, which actually has pressurized tanks, so it can keep deep-sea creatures, which is unique. One of the largest sharks' lifespans in captivity was a shark called Bertha. So it's in New York Aquarium, and she lived from 1965 to 2008 in the aquarium. She was quite an old shark, 45 years, I believe. And there was the most common species of shark you'll see in an aquarium is white-tip reef sharks, because they are a docile species and actually live in colorful reefs. So you'll see them a lot diving as well in areas like Hawaii and other places in the Pacific and Southern Atlantic Oceans. There's also many different species of sharks that are very docile, like the angel shark. You'll see that at Monterey Bay Aquarium in California. Those are bottom-dwelling sharks. Monterey Bay has been rated one of the best places to see deep sea life, as well as sharks, because they have one of the largest aquariums in the United States. You can also see sharks in the National Aquarium in Baltimore. There are many places you can see sharks in the world. Even if you're not one for aquariums, I know some people aren't, you can actually go use ecotourism to your advantage. It's a big thing now, and many places offer shark cage diving. You can go into a shark cage and actually encounter sharks close up. It's one of the bigger parts of ecotourism now, is the ocean. A lot of people are going whale watching and such, and this actually helps a lot of places accumulate money, so it's becoming a very big thing. A lot of people are doing it. And sharks are one of my favorite creatures, having volunteered with them for quite a while and wanting to become a marine vet. It's my job to learn about them. I find it very interesting. We find many species of sharks, and we are even discovering new ones recently. Recently, we find species almost weekly in the world that we have not known in science, including a species of cavefish which was recently found in a museum archive that we didn't know the species existed because it's extinct now, but was found in a jar within a museum archive that people were going through, and they documented it as a new species. And that brings me to the next subject. Next month, we will be talking about endangered species, and it'll be about Psittaciformes, the parrot family, because recently we have found footage of a Spix macaw, one of the rarest creatures in the world, in the wild. So I will see you next month when we talk about Psittaciformes, the parrot family. And have a good rest of your day. And I will see you next month.